We present a flexible framework for interactive multi-perspective visualization. Here the user constructs a multi-perspective visualization interactively, in top-down fashion, starting with the conventional image and modifying the viewpoint for individual image regions. Once the left side of the image captures the feature of interest, here a lake, the user adjusts the viewpoint for the right side. The frasta of the two viewpoints are illustrated with blue and red in the overhead view. The two viewpoints are integrated into a continuous multi-perspective image. The multi-perspective image is rendered efficiently on the GPU, which enables interactive visualization of dynamic datasets. The user can smoothly transition back and forth between the multi-perspective and the conventional visualization of the dataset. The top-down construction is applicable to 3D datasets such as this protein molecule. Starting from the main perspective, the user selects a rectangular region of interest. Then the user orbits the viewpoint of the region of interest. The user can select additional regions of interest. The viewpoint of each region of interest is adjusted individually. Image distortion is limited to the transition region. The data outside the transition region or inside the focus regions is visualized distortion-free with the conventional camera, albeit from different viewpoints. Any number of regions of interest are supported as long as they do not overlap. As before, the user can smoothly transition between multi-perspective and conventional visualization. Our framework also enables bottom-up construction of multi-perspective visualizations. Here the user navigates through the dataset with a conventional camera. A first image of interest is saved. Once a second image of interest is found, the system automatically connects the two images with context to obtain a continuous multi-perspective visualization. As before, the user can gradually switch back and forth between the multi-perspective and a conventional visualization of the dataset. The transition is implemented with the morph of the underlying multi-perspective camera into a conventional planar pinhole camera. Previous multi-perspective frameworks create discontinuities in between image regions with different viewpoints. The discontinuities have to be hidden behind geometry, which constrains the construction of the multi-perspective visualization and which is not always possible, as can be seen here for the sky. Our multi-perspective framework maintains continuity throughout the image. The sky is sampled continuously, which shows the airplane at all times. Consider two targets moving through an urban scene. As they move, they become occluded in a conventional planar pinhole camera visualization. Our framework enables tracking both targets, avoiding occlusions. The underlying camera model is modified automatically to circumvent occluders. The targets are imaged precisely where they would be seen in the absence of occluders, which conveys to the user the correct direction to the targets. The system bends the rays of the underlying camera as needed to avoid occlusions. The resulting projection distortion is highlighted in red. The multi-perspective visualization reverts automatically to a conventional visualization when the target becomes visible. The projection distortion can alternatively be visualized by overlaying a wireframe visualization of the undistorted dataset on top of the multi-perspective image. Our rendering pipeline can be modified to support raycasting to handle density datasets. The sampling rays march downstream from the root camera segment into the dataset, as opposed to forward rendering, where the vertices project upstream to the output image. Our framework incurs only a low overhead compared to conventional raycasting. The only additional computation required is to change ray direction when a piecewise linear ray crosses from one camera segment into the next. We have presented a flexible multi-perspective visualization framework that supports changing the viewpoint for individual image regions, connecting conventional images, and keeping tracked targets unoccluded. Our framework enables sampling focus regions at higher resolution and integrating them seamlessly into the surrounding context. However, our framework significantly extends the functionality of conventional focus+context visualization by supporting changing the viewpoints from which the focus regions are visualized in order to overcome occlusions.